Well, welcome to Algebra Review for Data Science, and this is coming from www.livedataprofits.com, and my name is Macrina Fagans, and you're in for a treat. I'm very excited that you have decided to go into data science. It's one of the most exciting IT fields out there right now, and it's just not going away with all the technology and virtual modalities coming our way. So I am very excited to bring on this review to you or for you. Thank you for joining us. The topics that we will cover, we will begin with the very basics. This is part one. I do have a part two to share with you guys. So we'll talk about the real numbers, natural numbers, whole numbers, integers, rationals, irrationals, complex numbers. And usually by now, those of you that took Algebra 1 and 2 in high school are probably starting to have some flashbacks, remembering your algebra teacher in high school. We'll talk about PEMDAS, the very popular acronym to help us with variables. And we'll go over the basic polynomial properties for addition, subtraction, multiplication, division. We'll definitely need them for when we work with equations. So to begin, the real numbers are a very interesting set of numbers. It covers all the numbers that we use with our fingers, plus the negative numbers. If you can think of credit and cash, so credit would be the negative integers, and cash is your positive. The rational numbers are those that we can symbolize as fractions, rational. You see the prefix ratio in that. That's because there's a fraction. And irrational is totally opposite of irrational. And the complex numbers are very interesting. We don't get to work with those too much, but those of you doing more of the advanced data science and cryptography and stuff like that, you'll get to see those numbers quite often. And the images that we're using in this presentation are coming from commons.wikimedia.org. And so the complex numbers have a real part in it, and that's why that's a bigger set. But let's continue. The natural numbers are the ones that we find in nature. If you can think of, like, right here, we have two birds. We have the mom dog, the female dog, and the pups right there. There's three of them. So that would be for the children. Anything that we count will be part of the set. They will have some bodies of water, and we go down a trail and can count the trees. That's your natural numbers. And the set for the natural numbers begins with one, and it can go on to infinity, which is that symbol that we see there at the very bottom on the left. And once again, Commons.Wikimedia is bringing on the images for us. Whole numbers, it's just like the natural numbers, but now we have zero. Whole numbers happen just about any place. So zero cars, three boys, zero plus the positive integers. You can think of that number set as the whole numbers. Integers. And right here, I used to teach high school for many years. I know that my Algebra 1 students did not want to go and talk about the integers, but we have the negative and the positive integers, and those we go back to the number line. Remember, that's in the center. The zero is kind of like your natural midpoint of this line. Anything on the left, it gets very, very small. Anything on the right, that's what we want, right? Especially money, the purple, you want to be very positive. So after the integers, which you'll see it in set notation with the Z, the rational with the Q, and the real with the R. That's the how the sets work. So the integers are inside of the rational. The rationals are inside of the real numbers. And as you work with data science, you will not be dealing with a lot of this because most of your job is going to be to do code and develop those mathematical models. But we do want you to have a strong foundation of your number set and uh, your number sense. So rational numbers, there's your fractions, and I can say that carpenters and construction personnel do very well in my class when they work with the fractions. They might not follow the mechanics that we do in algebra, but they come up with the right answer. So you have different ways to symbolize them. The shaded region right there on the right, the upper right-hand corner. We have 2/3, we have 4/6, and 6/9. And notice how all of those are equivalent fractions. Then you have different representations here using the number line, both negative and positive. And if you are rolling your eyes right about now, it's okay. This is just a review. I will give you some additional resources if you want to do more of the computation. But my goal doing this little tutorial is just to bring on the definitions and kind of guide you in the right direction. Well, irrational numbers are exactly the opposite of rational numbers, cannot be represented as a fraction. The decimals never repeat and the decimals never end. And some of the classic examples that you probably saw in Algebra 2, in Algebra 1, in high school, well, the square root of 2, square root of 3, the letter E, was it, which is actually a number. Pi, there's been in recent years new digits that have been discovered. The natural logarithm of 2, e to the x, pi to the n. Well, to begin with, those bases were already irrational. So if you use any powers on them, they'll be irrational numbers as well. So this is where you come in with your data science. It is good that you will have the computing power to help us figure out how to do the irrational numbers. The complex numbers are the biggest set of numbers that we will have, that we'll talk about. And this continues on. There's many different systems of numbers out there in mathematics, and it all depends how deep you want to go into this. But the complex numbers have a real part, which is usually what we push here for x. So if you have a 2 plus 3i, the 2 is your real part, and the 3i is your imaginary part. If you see it on a 2D plane, you see how the yi axis and you have your x representing the real portion. When we combine them, we'll do like we do regular constants and variables. If they're like terms, we'll go ahead and put them together. And in this case, 2 minus 1 will give you 1, and 3i positive minus 4i gives you a negative I. So the addition of these guys will be just like we do constants and variables in algebra. And if you've forgotten the definition for I came about from getting the square root of a negative 1. So I to the second power will be negative 1. And we'll use that little fact to multiply and be able to work with complex numbers if we need to. So FOIL, what is FOIL? FOIL is we use that acronym for first, outer, inner, and last. And we use it when we want to expand binomials. So we have two binomials in particular that we want to multiply together. So if you look at these two numbers, these complex numbers, 2 plus 3i and negative 1 minus 4i, the first terms that we have is the 2 times the negative 1. The second, or the outer, is the 2 and the negative 4i. The inner is the 3i and the negative 1, and the outer is 3i and the negative 4i. So once we multiply those, we end up with a negative 2 minus 8i minus 3i minus 12i squared. But remember, by definition, I squared is negative 1. So when we combine that 8i and 3i, we get a negative 11i. Then we bring on that negative 1 from the I squared. So our complex number is going to become 10 minus 11i. Now, if all of this, if your head's spinning already, it's all good. I don't want you to get overwhelmed. I will provide you with additional resources that you can use to help you if you are like, I really don't remember that property. My goal for this small tutorial is just to look at the bigger picture for someone that has been maybe doing math for a while. Go, let me just quickly browse through the slides and see what's going on. Dividing complex numbers is a little different than expected. It's not intuitive. We actually are going to multiply by something called the conjugate. We want to completely remove all the i's from the denominator, and that's how we come up with a negative 1 plus 4i. So the conjugate changes the sign of the complex, I'm sorry, complex part of your of your number. So you see how you had a negative for I, well now it becomes a positive for I, and you'll see here in a second why that will work out. So we go ahead and do our FOIL. So the 2 times the negative 1, the 2 times the 4i, the 3i times the negative 1, the 3i times the 4i. And we'll do the same for the bottom, the denominator, negative 1 times negative 1, negative 1 times 4i, negative 4i times negative 1, negative 4i times 4i. And once we clean this up a little bit, we get a negative 2, we get a positive 8i, a negative 3i, a positive 12i squared. So you are using your integers, you are using the definition of I squared. At the bottom, the denominator comes up to a positive 1 minus for I plus for I minus 16i squared. So now you begin to see that some of the terms at the bottom are canceling out once you collect like terms at the top, and we use the definition of I squared. We end up with a negative 2 plus 5i and a negative 12. The I square is negative 1, so when you multiply it times a positive 12, that's where the negative 12 came from. The bottom, the 4 i's go away because they're additive inverses, so that goes away. The 16, the negative 16 I squared, once again, the I squared was a negative 1 times a positive give us a 17. And if you want to write it as your real form and your complex form, then that would be your complex number. But the one before the negative 14 plus 5i divided by 17 would also work. It just depends on the preference. I know a lot of my math buddies will probably want to see that broken into the real portion and the complex portion, but it just all depends how technical you want to get on that. And this is just a high the 10,000 feet view, just so you can remember your numbers and your different number sets for the complex numbers. So the natural numbers were the ones that we started. They're in nature. That is contained in the integers, that's contained in the rationals is contained in the real numbers, is contained in the complex numbers. And there's one here that we didn't talk too much about, but the K stands for hybrid numbers, and I will not talk about those. But you also have some in this visual here from Commons.Wikimedia. They have the dual numbers and they have the hyperbolic perplex numbers. And if you are going to be going into pure math, data science field, you might have to work with those, but I'll let you figure those out. Let's talk a little bit about variables. So when we simplify, we want to have the letters have to have the same powers for us to be able to combine them. So if you look at the first example, you have 2a plus 2s. We cannot do any much more with that. So that would be our answer for simplifying. You have 2b plus b minus 3b. Remember that when you just have b, there is that invisible 1 in front, so you can account for it by doing 2 plus 1 gives you a 3. And these end up being additive inverses, so we get a 0. If we begin getting a little more advanced, we have 4 times the quantity u plus 3v minus 5 times the quantity u minus v. So we would want to use what we call the distributive property. So you want to distribute that 4 into whatever is inside the parentheses. So you'll come up with the 4u plus 12v minus 5u plus a 5v. So math is amazing. You are building onto the previous concept, and so we started very elementary with the number sets, and now we're moving on to our algebraic properties. We want to combine like terms, so all the ones that have a u, we put them together. We end up with a negative u. All the ones that had a v, when we count them, will give us a 17 v, and that would be our final answer for that third example. Example 4, same story. You go ahead and distribute. So negative 5 times p, negative 5p, negative 5 times negative 4 gives you positive. Remember, negative times negative is positive, 20. You have a 6 times p and 6 times a negative 1. And when we go ahead and anything that has the same letter, we put them together, we end up with just one p. And then 20 minus 6 plus 2 gives us a positive 16. And variables, PEMDAS. PEMDAS stands for please excuse my dear Aunt Sally. And this little acronym has helped so many thousands, by now millions of children and young students and all more mature students get through doing algebra. So when we are simplifying expressions or working even with our equations, we want to see if there's any grouping symbols that we can go ahead and take care of. Then we'll do the exponents. We'll do multiplication, division as we read it from left to right. So very, very important that we do get that across left to right. And adding and subtracting, we could add first, subtract um, second, or vice versa. But we do want to have that process going. Well, we are going to be moving to an example of PEMDAS, which is please excuse my dear Aunt Sally. So we'll begin with the parentheses here. You see how this exponent only affects that 3. So be careful with that. That negative will come later. So you do want to expand that. 3 times 3 will give you a 9, which is a negative 9 plus 4 gives you a negative 5. And we can go ahead and now do the exponent. Negative times negative times negative gives us a negative 125 times 2 gives us a negative 250 divided by 2 will give us a negative 125. Now, Well, let me back up. Let me back up. Let me only talk about forget that negative 2 for a sec. I was speaking too fast there. I forgot I have all this denominator going on here. So 4 times 4 times 4 will give us a 64 minus 2 gives us a 62, which is the reason why we had to divide by 2 to be able to reduce. There we go. We got it. All right, well, let's look at an example of PEMDAS, and we're going to use variables now. So we're going to go to the very inside of the grouping symbols. You have a nested case here. You have the x minus 1, that's multiplying that minus 7, and that's in a bracket. That's multiplied by the 3x to the third. So we definitely want to distribute that negative 7. So we'll end up with negative 7x plus 7. And we will go ahead and keep that 3x to the third in front, the front end, the back end, to give us, just keep on doing one step at a time. We combine like terms, so the 6 and the 7 gives us that 13. Then see we had those brackets here and we have to distribute that 3x to the third. So you're gonna find yourself doing lots of distributions in algebra. And I'm sure you're starting to remember those. So we have a negative 21x to the third, a 39x to the third, and it just happens that we also have that 9x to the third, which is a like term with the 39x to the third. Now let's switch gears and begin to move to the more advanced topics. And all of this is coming from Algebra 1, a little bit of Algebra 2. But the basic polynomial properties, polynomials have a degree, and that will give it the name of that polynomial. Remember, the word poly means many, nomial means term. And in math, every time you have a plus or a minus, that's a different term. So the first one here, we have a binomial, and it's linear because the degree is 1. The leading term is x and the power is 1. It's not written there. We don't write it, but we call those linear terms. So this is a linear binomial. The second example that we have here only has one term and it's got a power of 2. So that's quadratic monomial. Then we have 3 terms here. So we call that a cubic trinomial. Cubic is the leading degree here is a 3. So that's a cubic. The properties of addition in polynomials. Um, Commutative means that we can switch the 2 and the 3, and if we add them, it's not going to affect the end result. So 2 plus 3 and 3 plus 2, it's equal to 5. Associative property, we also have that in addition. That means if we are regrouping the terms, we'll get the same answer. So notice how here we added the 2 plus the 1 is 3, plus 3 gives you 6. And you can do the 1 plus the 3 gives you 4 plus 2 gives you 6. Now, these don't always hold for all the operations, so you're going to have to keep an eye on those. The identity is a concept that will get us the same answer back when we apply that computation. So in addition, the identity is 0. 0 does not affect any of your results if you are adding polynomials. All right, we're moving on to the properties of subtraction. So commutative property, it does not hold in subtraction because you have 2 minus 3 will give us a negative 1. However, 3 minus 2 gives us a positive 1, so it's not going to work for subtraction. Associative property does not work either. So 2 minus 1 will give minus a 3 will give us a negative 2 if we group the 2 minus 1. But what happens when we group the 1 minus 3? We're getting a negative 2. And then we have the subtracting part. So that will give you a 4. So it is not working. Now, the identity, however, continues to be zero, and that is okay. That is okay. So don't be thinking, oh, all the properties have to hold for all the operations. No, it doesn't work like that in arithmetic or in algebra. Distributed property, we've been doing this. You get to do it a lot in algebra. So you basically multiply to clear out those parentheses. So 3x plus 18 for the first one. Commutative definitely works for multiplication. 5 times 6 and 6 times 5 are the same. Associative also works for multiplication. And the identity, it becomes 1. So it was 0 for addition and subtraction. For multiplication, now the identity is 1. We can always use that one. And division is not commutative, it's not associative, but we do have the identity of 1, and that would work for us. So division is it's a little interesting, the different process than addition and subtraction. Now, these properties of equality are so, so important for us because in algebra, we're trying to solve. We want to find a solution or a set of numbers or values or variables that will satisfy that solution. So, solution set, it could be more than one number, or we could have no solution. But in adding whatever we add to one side, we have to add the same exact quantity to the other side. And and that will let us know that then A and C will continue to have that balance. So subtracting, if we subtract one quantity from one side, we have to subtract it from the other side. So we kind of keep that balance. That's what this means. If A is equal to C, then to keep that quantity the same or being equal to each other, we have to have the same quantity going on one side and the other side. Same for multiplication, same for division. We'll use that trick a lot to help us solve equations, and that's going to be in part two. So, well, we talked so much today. I did, and you are taking notes. But basically, what we covered, oh, that went too fast. We covered the real numbers, and we also talked about complex numbers and the hybrid numbers, which are very get to be very interesting. We work with some variables. We work with the basic polynomial properties, and once we do part two, we're going to be going into more examples. In part two, we'll pick it up right here with equations. We'll talk about inequalities. We'll talk about graphs, functions, series, and sums. So as you can see, the topics are progressing into more difficulty, but you got this. You got this. Working with data science, the bigger part of your job is being able to code. You need to be able to code and do the math modeling and apply the theory to all the problem solving that they want you to do, the algorithms. So you got this. Just do one thing at a time. The last topic that I'll cover for you in part two will be conics. And let me see. I do have one super wonderful additional resource, which I want you to consider Khan Academy. I mean, these guys are amazing. That you can register for one of the classes, and I did a 20 plus minutes, just really quick overview of how things work. And I am looking at the list of topics that I have for part two, and we might even have to do a part three now, I'm thinking, but we'll see how that goes. It was a pleasure to have you. Once again, my name is Professor Fagans, Macrina Fagans, bringing you this little algebra review for data science, and it's not little. I think it's big. It's a lot to cover, but you did great. Thank you so much for joining us. And you can always visit our website. I am uploading new resources and new information and data to help you become super successful at data science. And that's livedataprofits.com. Thank you.